And I just tried some more off camera and it's getting most of it right now. Okay, got this 8 correct. And I found that if I slant the 1 slightly, I think it gets it correct. No? Wow. It just does not want to work on camera. 0 seemed to be pretty consistent though. No, it just doesn't want to work on camera. What? Hold on. Okay, so it does get. I wouldn't say it's 80% though, or maybe I'm just my handwriting is just different from people since I am writing with a mouse right now. 5. Let's try 5. This is very offset though. Okay, 6. No, 7. Okay, 4. 4 it gets right. 3. Yeah, so it does get. It is definitely better than just randomly guessing and checking. And although it doesn't feel like 80%, according to my testing, it should be getting about 88% of the things right, at least from the testing set. Well, if my code doesn't include like a leak, that is, uh, yeah, it should have been well separated here, and I didn't touch any of the data, the test data, so I'm just gonna believe the statistic that this statistic over here. In any case, I completed a two hidden layer neural network, and although it's not perfect, like there's definitely a lot of room for improvement. As you can see, it didn't really get many of my handwriting correct, but I did learn a lot of things when building this. So initially, I started with a single layer network over here. There's a lot of like testing up here, and then this is the main block for my single network, my single layer network. And already those that know what they are doing, they already can tell that this block is going to be redundant. And I think this is the most important thing that you should know if you're like me and you started working on this neural network without looking at guides and just using your intuition. Yeah, know that there's a NumPy function called np.outer, and it kind of helps a lot with the time optimization, and you don't have to write big for loops essentially. My If you take a look at my attempt at making a generalizable neural network, I ran into a lot of problems, and look at how many layers of for loops there are here. So yeah, I put in I think about 3 4 weeks, non not every day but quite consistently, and this is the result of that. I took a break after having no progress for a while because trying to find the problem in this huge chunk of code was obviously very mentally taxing. And I came back with a fresh mindset. I decided I want to do everything. Uh, don't make it generalizable. Do it step by step first, and then if it works, then it works. And it turned out it did work. I did manage to get about 88%. That's much better than the single layers about 53% I got on the single layer. So yeah, adding layers to the neural network did indeed increase uh, the accuracy. Anyway, I getting very sidetracked right now. Moving on to the main takeaways. Don't jump into generalizability at first. Like, I finished the single layer network and I thought, how do I make this better? And I wanted to try to immediately generalize to like any number of hidden layers. Don't do that. Start go step by step. I think it'll save you a bit of time because I tried to make it generalizable, and this is obviously very messy code as well. That's probably the reason why it doesn't work, because number one, I didn't know of the existence of this magical function, this one, np.outer. So this is what it does, and this will save you a lot of time, and it's also very efficient because the people that made NumPy, they optimize the heck out of it. But anyway, know that this exists, and this is actually my second tip. This is just very important, and also the here, yeah, you can transpose the weight and use matrix multiplication. Don't do it manually like I did here. This leads to a lot of trouble probably. Also, when I'm looking for previous the way the previous activation affects the cost, I divided by the length to find the average, because I thought, um, why not? Don't do that. Apparently, it dilutes things. And lastly, I had to. I think this helps. I'm not sure, but I think it helps. You scale it into 0 and 1. So your handwriting, the 28 by 28 pixel image, it will be values from range 0 to 300 something, right? I think scale that down into 0 and 1, because your sigmoid functions will use 0 and 1. They output 0 and 1, and then so the next layer also takes in 0 and 1. If you want things to be uniform and easily understandable without having to think about the scale, then you just scale everything down to the same in between 0 and 1. So yeah, that's about everything I learned. But most importantly, I think it's you should try. You should try to build one on your own. I feel like I really managed to cement my understanding of how a neural network works from from building this project. Watching just the Chi Blue One Brown videos, it gave me maybe like 70% of what I need to know. But actually trying to implement it, you see that there's a lot more that he doesn't mention, like how you would want to initialize your weights, the scale you would want to use Xavier initialization. At least that's what I used. It worked here. Like I have 88% accuracy. It should be working. And yeah, just try and build it, and you'll see that it's much more complicated. If you watch the Chi Blue One Brown video, start, it's not that complicated. I understand what you feel. I was there too. And then I tried to get into implementing it, and because I'm such a newbie coder, I'm not very familiar with NumPy and code in general. I It took me a while to like really process all the implementation, and especially since I didn't even think of trying to like optimize some of these. I did the matrix operations kind of by hand almost. It's very manual. I take from the list and then I multiply down the column and things like that. Don't don't do that. You can I'm going to be including all of my progress to document it somewhere. So if you're watching and you want to see what I did wrong here in the case that I wanted to generalize, then yeah, you can try to find the mistake. I have a feeling it's probably a logical mistake because it's so messy and yeah, it's just not good coding. So yeah, have a go at it yourself. Thank you.